After this finding the integrating factor, we used to find the solution for this equation, and the solution for this equation is given by y into integrating factor equal to q into integrating factor into dx plus c. So this is the solution for linear in y. So in linear in u, instead of y, we are going to write u, and all the things will remain the same. So our solution will be u into integrating factor equal to integration of q into integrating factor into dx plus c. So here we have replaced y by u because this is the linear equation in u and this is the solution for linear equation in y. So now we are going to solve this. So u into integrating factor equal to integration of q into integrating factor into dx plus c. So this is the solution. What is u? We have substituted u as tan y, and integrating factor we have found out as e raised to x square. Integration of q. What is q? As you can see here, the q is this part. So the q is x cube. What is integrating factor? Is e raised to x square into dx plus c. So we have to integrate this part. Consider only this integration, and it is the difficult integration, like it is a different, we cannot have any direct formula or any direct property to solve this integration. So consider this integration separately, which is x cube into x square. So now if we substitute x square, so now what I am going to do, I am going to write instead of x cube and x square and 1x here. So this x square, we can substitute x square as t, and if I take the derivative here, which is 2x into dx equal to t. So x into dx is t by 2. So as you can see, why I have taken this x with dx, so that x into dx can be directly replaced by dt by 2. This should be dt. So x into dx can be replaced by dt by 2. X square we are substituting as t, and this x square we are substituting as t. So this integration can be modified as t into e raised to t dt. So this is nothing but our simple u into v rule. So what is u into v rule? So u into v rule of integration is we keep u as it is and we integrate v with respect to dx minus integration of derivative of u, integration of v dx, and then again derivative with respect to dx. So this is the general formula. So again we are going to apply this general formula. So first we will keep u as t and v as e raised to t. First we will keep u as it is and we integrate e raised to t. So what is integration of e raised to t? Integration of e raised to t is e raised to t minus then this integration sign, derivative of u, that is t, derivative of t is 1, then integration of v, integration of v is e raised to t dt. Then again we have to integrate this part, which is e raised to t. So this is nothing but t into e raised to t minus integration of 1 into e raised to t is nothing but e raised to t. So this is how we solve the integration of this part, which is nothing but t e raised to t minus 1. So we are going to substitute this part in this equation, but before that we are going to substitute, because in this we have only x term, so here we are going to substitute back what is t. So this integration will be e raised to t, and t is x square into t minus 1. So here t is x square minus 1 plus c, and this will be tan y into e raised to x square. So this is the solution of this equation, and this is how we solve the type 4a type of problem. So more such problems we will see in our next video, so stay tuned for our future lectures.